Alright, we've been looking at some classic problems of synchronization, and the next one we're going to see is the reader-writer problem. So this borrows from concepts we've learned in the critical section problem as well as in the one we just saw before this, which is the producer-consumer problem. So I'll first explain the premise, then we'll look at what the actual problem statement is, and we will again look at one semaphore-based solution. So again, in the reader-writer problem, we have two types of processes. One is called reader processes, the other is called writer processes. Let us say a database is to be shared among several concurrent processes, as in you have multiple processes being executed at more or less the same time concurrently, and they're all going to be working with the same memory locations or the same data. Now some of these may only want to read the database, which we are obviously going to be calling reader processes. Some others may want to update, that is, they may also want to write onto the database. Such processes we will be referring to as writers. So here is our premise. We have some reader processes and some writer processes, both of which are going to be working with the same data. Note that in the producer-consumer problem, which was the immediate previous problem we looked at, there was only one producer and one consumer. Here that is not necessarily the case. You might have multiple readers and multiple writers working with the same data at the same time. Now the readers-writers problem is an umbrella term which refers to various kinds of clashes which can occur within this kind of a premise where you have readers, writers and the same data. Now there are different variants because, as I said, different types of clashes can happen. There are two main variants which we will be looking at, the first reader-writer problem and the second reader-writer problem respectively. So the first variant is more focused on readers. So what it states is that no reader should be kept waiting unless a writer has already obtained permission to use the object. So okay, before I explain the specific variants, from our knowledge of the critical section problem, we all agree that writing is in some sense a more critical process as compared to reading, right? Because you can have multiple processes all reading from the same data location at the same time, and that is not going to corrupt your data in any way. But if one process is writing onto a particular location, then you cannot have another process working with the same data at all. Whether the second process also wants to be writing or whether it just wants to read, it has to wait till the first process has finished writing, because otherwise if two processes are writing onto the same data location at the same time, one is going to get overwritten. Or if one process is writing and one process is reading at the same time, it might end up reading the wrong value. It is meant to have read the value before overwriting, but it read the one after overwriting, or vice versa. So all sorts of things can go wrong when you have one process which is writing and another process is doing anything for that matter concurrently on the same database, right? So in that sense, we know that writing is a critical task. So when one process is writing onto a database, there should be absolutely no interruptions whatsoever on that same data location. Reading, whereas, can take place concurrently. So that much we all agree upon. So with that prior knowledge, let's get into the variants. We have the first reader-writer problem, which says no reader must be kept waiting unless a writer has already obtained permission to use the share object. So if a writer has obtained permission, so if a writer process has acquired the lock or semaphore or whatever, then obviously writing being more critical, this writer will be given full and absolute permission to work on that object, resource, data location, whatever. All other processes, whether they want to read or write, they will have to wait. Why so? Because as we just saw, writing is more critical. But if no writer has currently made any claim on the shared object in question, then a reader must not be kept waiting for the sake of a writer which may come in future. So basically the idea is, let's say you have some location which is currently not being accessed by any processes. This process P1 arrives and it only wants to read this location. So P1 is a reader process. It should not be kept waiting indefinitely under the idea that some writer process might come in between and it will have to be given priority, so I will ask P1 to wait. Or if some other reader process is reading, let's say P2 is currently reading this location, P1 also being a reader should be allowed to also read concurrently. No reader should wait for other readers to finish. Unless a writer has already obtained permission, no reader should be kept waiting. That's the idea. So at the very core, the first variant of the reader-writer problem says, if some writer process is currently writing onto your shared location, allow it to finish, make all other processes wait. If no writer is writing and a reader comes asking for permission to access, it should be granted permission immediately. It should not be made to wait. That is the first reader-writer problem. Moving on to the second variant, it says, once a writer is ready, the writer should perform its writing as soon as possible. So if a writer is waiting, no new readers may start reading. So let's say P1 is currently reading the resource, P2 and P3 are waiting to read, and then P4 comes wanting to write. As soon as P1 is done, P4 should be given permission to write, even though there are two readers already waiting. As soon as a writer is ready, writer should be allowed to perform its task at the earliest. That is the second version, which focuses more on writers. So these are two variants of the reader-writer problem, and a solution to either problem may result in starvation. So in the first case, we're trying to give more and more priority to readers, right? So it could be possible that readers keep coming up, so a writer process has to keep waiting indefinitely. In the second case, vice versa. It is possible that writers keep coming up, so a reader process is forced to wait indefinitely, and this indefinite waiting is what we call starvation. So that is the premise of the reader-writer problem, and the idea is you need to come up with a solution which will meet the constraints of the problem. So if you're trying to solve the first version, then your solution has to be such that readers are given preference, they are not kept waiting unless a writer is already writing. If you are trying to solve the second version, then the writer should be given preference, so on and so forth, and your solution should also avoid resulting in a starvation situation. So we are going to try and come up with a semaphore based solution for the first variant of the reader-writer problem now.